Off you go.
Great. Thank you so much for the kind introduction. Can everybody hear me also in the back rows? Okay. Just let me know, I will speak up. So today I would like to talk to you about tool-augmented multimodal medical reasoning, which is a very long title that says I wasn't really sure what to talk about. So I just started a new research group at ETH Zurich last fall. We're still in the phase of building up the group. I have right now 2.5 PhD students. They're all alive. And our focus is to develop and evaluate flexible medical foundation models and AI agents and agent systems that are grounded in multimodal medical knowledge. To me, the story kind of began in medicine. So I studied medicine, and later on, I was really excited to do more research and get, again, this feeling of truly trying to understand what's happening underneath, which in medicine, I felt I lost a little bit towards the end because it felt more like I'm hopping around on a decision tree rather than I'm digging the body at night and try to understand how the organs work. And during my PhD, I actually worked quite a bit on the old school machine learning models that would do like early warning systems based on time series and so on. And after that, I was a bit frustrated that you can train a classic model on all kinds of patients. It can see hundreds of thousands of patients, and the model would still not really know anything about medicine. So when I joined Jure Leskowitz's group at Stanford, my mission was, can we somehow instill all the medical knowledge that's already out there and that all the clinicians already know, can we instill that somehow into models? Because I think this is similar to the pre-trained phenomenon that we see in image models for 10 years or more. It's quite natural that this should also work in the medical domain with medical knowledge that we can use for pre-training. And this is what brought me to where I am now. So my group works at the this interface of medicine and AI, and we care a lot about multimodal LLMs, agent systems, but also benchmarking capabilities and information retrieval and more personalized tasks. And with that, I would like to throw you an example into your face. So I expect that many of you are not MDs by training, so it might not be very obvious what you are seeing here. Does anyone have an idea what this could be? So if you don't have an idea, that's actually not so bad, because I recently asked GPT-4o and it also didn't have an idea. So it gave a differential diagnosis. And among all the options, the true answer is not there, which is, this is a very rare rash that can appear when you have lung cancer. And when you take this image and do a Google image search, you will actually find the real image. You could also find very similar looking images. This just illustrates the power of using external tools. So the right solution is here, this erythema giratum repens, which I think is a very beautiful dermatology disease, which is why I use this as an example. Already, I think a year ago, we released one preprint where we played around with Google image search and other image search strategies, where we found that if you just take a basic LLM, could be API-based or not, and you expose some tool to it, like image search, it will become much, much better at doing knowledge-intense visual question answering. This is in the general domain. We observed improvements of like 40% on different knowledge-intense benchmarks. This is just one example, but I think tool use in LLMs should go much beyond just doing search and retrieval. For instance, I remember when I was doing the rounds as an intern in the hospital, And I would talk to a patient, I would immediately forget everything the patient would tell to me after like 2 minutes. Maybe that's just, yeah. Maybe that's why I'm here and not working in the clinic. But this motivated me to think more about, can we build tools for agents to take notes, to memorize, and to actually write down on a scratch pad all the important things to follow up. And there's more tools that we can use. We can actually analyze images to segmentation and whatnot. We can also tell agents to invoke reasoning tools. If we want, we can look at them like that. Or we can, of course, dream up all kinds of environments and agents, engines for a model to use. So this is a slightly more philosophical slide, namely, so why do we even need tools? Because 2 years ago or 3 years ago, where everybody was super, super stoked about the great new brave world that LLMs will bring, I think there was a time where many people believed you could just throw all the data into one big model that is pre-trained on all the data, and then that model will be able to do everything. And I also believed that for some time. And I think this is a very ancient discussion in computer science. It goes back 50 years maybe or more, which is, can you just take a network and throw data at it and use some algorithms to learn what's happening underneath or not? And right now, I think there's a lot of, we have seen a lot of slogans over the last years that try to tell us, this is the silver bullet, and this will solve all your problems. And yeah, I think we right now don't have the silver bullet. And I think tool use will be required, even if model capabilities become better, because we still, especially in the medical domain, we need reliability. And it is not enough to have a model that gets you 90% of the performance, but you actually need to really go to the last mile and really go to a level of quality where you can say, okay, this is now safe to use in clinical practice. Just to give another illustrative example, for instance, imagine a patient comes to you and says, I have abdominal pain. There's like an entire range of different things that could be wrong with that patient. And this is just a random list of differentials. It could be actually much more. There's a long tail of thousands of things that could be wrong with that patient. And for many of those diagnoses, you need to do very different things that are not aligned with each other, but you have finite resources. So you need to think which differentials are actually likely or unlikely, and which ones, if you miss them, even if they're unlikely, will cause a lot of problem, because you don't want to send home a patient who has an aortic aneurysm. So the medical domain is very complex, which I think is a great thing. That will actually innovate new methods. But it also means we need to think very carefully how we trust a model's reliability in that domain. And now, with this build, I would like to pivot over to some ongoing and recent works where we try to build tools that then LLMs and MLLMs can use in the medical domain. I think one of the earliest works I've been involved in for trying to think of a kind of operating system style framework for improving LLMs in the medical domain was Almanac, which was led by Cyril Zacher, who's now at Hugging Face, and back then we both were at Stanford. And that was, yeah, I think it's more than 2 years ago now that we released that, where we thought actually it's extremely unreliable to just have an LLM responding to medical questions. It would be much better if we had some kind of vector store where we can have all the guidelines in there, we can have formulas in there, and we hook everything up together such that if the LLM realizes now it needs to do a calculation, we use a Python interface and do the calculation and so on. And at the end, we reply a response that is grounded in the guidelines. And this is a very early example. I think by now, many more things have been happening over the last 2 years. This one is a more recent example. We released that just 2 days ago, which is called Myriad, where we thought, why don't we take all the medical knowledge we can find from the literature and rephrase it passage by passage into a massive scale data set of medical questions and answers, which each of them is grounded in the medical literature. And this we can then surface to LLMs, and they can use that using RAG. And we also used clinical experts to annotate actually a small set of this data, and then we can correlate that against automated approaches of annotations. And what we find with this data set that we openly released, it improves RAG. So even if you compare the same source text against Myriad that was used in the rephrasing, it will improve the RAG pipeline. We show that it helps detecting hallucinations in the medical domain. And we even have a data set that we can do retriever training now. This is just in the text world, but I think more and more of those approaches will also become interesting in the multimodal domain. I think there's also a big synthetic data set that Stanford released, and it might even be here at CVPR, I think, called Biomedica. I think that's also a very exciting approach. And from that point, we also wanted to go a step further and say, maybe it's not only helpful for LLMs to have this type of operational knowledge, but maybe it's also interesting for humans. So we built this little demo which is a map that humans can actually fly around in and explore and have all the little dots. Each dot represents one QA pair, and the source and the journal, and can actually explore that. And you see, you can even do keyword search, and it's quite nicely organized by topic. So the goal with that is that actually clinical users can more easily interact with this. Now, we have actually heard quite a bit about agent systems today already. So I need to think on the fly a bit how to best react to that. But one thing that I just want to reiterate is the classic benchmarks for evaluating medical foundation models, especially in the language domain, they kind of have been saturated. And what I found very disturbing about it is that nobody really knows why. Because I remember the time 2022, 2023, where most of the progress that happened on the USMLE benchmark happened due to a single person, basically. So the BioLink Bird and Biomed LM and Dragon, they were all first authored, I think, or co-first authored by one person that I know. And somehow, all of a sudden, the performance skyrockets to 80, 90%. And yeah, nobody really knows what those models were trained on, how much overlap is there, how much is it memorization, how much is it generalization. But so even though we don't know that, we know that this benchmark is not really useful anymore. Also, there's many clinicians who criticize the benchmarks for other reasons. And we thought, actually, it's actually much more interesting, instead of just having this static QA benchmarks, to think much more about how can we use agent systems to evaluate LLM backbones and MLLM backbones. And so we started building this agent clinic a year ago, which Pranav also mentioned before, where we actually have a bunch of tools. It could be PubMed or other types of databases hooked up to the system. And the doctor agent can then talk to a patient agent about the same case that we would, for instance, find in a USMLE problem. And by doing this apples-to-apples comparison, we actually found that most models drop drastically in performance. Some of the open source models, like the Llama models, you see they might drop 10-fold in their accuracy. And what I'm very excited about with this general agent system setup for evaluation. So this is not like Amy, we're not proposing this is a new model, but this is an evaluation setting. And in this evaluation setting, we find that we can also start collecting soft metrics, which I think is very interesting from a clinical perspective. So not only can we say, did the model or the doctor agent get the diagnosis right? Not only can we look at, was the sequence of steps the right actions, but we can also start asking the patient after the fact and can do some kind of post-mortem and say, like, how would you rate the doctor agent from 1 to 10? And will you now comply with the diagnosis or the suggested treatments that the doctor agent gave you? Will you go to a next follow-up meeting? Those are all like soft metrics that, of course, will be most useful if real flesh and blood humans provide them. But I still wanted to just mention that. I think this is also an interesting new domain that we can tap into here. Most recently, I also got more and more interested in how agent systems can be used for research. So this is an example we released, I think, 2 months ago, where we show that if you take agent systems that collaborate in labs, they will actually, so this is focusing on LLM research. We actually found that those models, those agent systems will actually progress faster if they have some shared repository where they can push and pull their reports to and from. Just as a little teaser. Well, what comes next? So I think this or next week, we will release a bunch of new preprints. I'm very excited about that. I won't go too much into detail here. I just want to tease. So I think we're building some very hard benchmarks for multimodal reasoning in the medical context, but also outside of them. And I think that's an interesting direction, because usually those hard benchmarks, they show just how much the current models are still lacking. And I'm very excited to talk about this in the next opportunity. So to summarize, I think the medical domain remains very challenging. While there's many other domains that kind of are being gobbled up or swallowed up by the recent advances, I think the medical domain is quite safe in the sense that it has a bunch of big problems. So in medical decision-making, we have a very, very large action space. For instance, if you think about robotics or any other type of setup where you have agents that can make movements, or you have a very constrained action space. But in medical diagnostics, for instance, you not only have to think about, oh, what is the right drug that I give now, but you have to think about, like, which combination of drug do I need to give, and at which doses, and what's the specific comorbidities of that patient, and so on. So the action space is really, really large. Another problem is the lack of ground truth. So quite often we don't really have this verifiable signal that we have in coding or in doing math. And I think those are all great challenges that will inspire new methods downstream. Then finally, I think I like to think of the problem of incomplete information and uncertainty, which is deeply rooted in the medical domain. And I think this will also be very interesting to follow up more in this direction with agent systems that specifically try to systematically reduce uncertainty. Great. And I think all those challenges, they should actually not demotivate us. This is not a negative final slide. This is actually a positive slide, because I truly believe in the potential that the method side has when it's being inspired by complex domains like medicine. With that, I would like to thank you for your attention, and I'm open to a question if you have found.
Thank you. That seems like it is a very critical problem, and yes, we need to really figure out what these hard benchmarks are, because they're saturated. All right, looks like we have some questions from the audience. Okay.
Thank you very much for talk. I was just wondering, as a clinician yourself, there seems to be this problem of trust amongst clinicians in developing AI or adopting models in the clinic. I was wondering if you could comment a little bit on how far do you think the models research laboratory are from like real, actual clinical implementation. And I appreciate your comments on benchmarking difficulties. To what degree does like very practical human factors like clinician trust play into that equation?
Okay.
Just based on your own clinical experience.
Yeah, my own clinical experience is very limited. So I never really worked as a clinician, but after studies I pivoted. So just as a disclaimer, regarding the readiness level of LLMs for the clinical setup, I think many models are good enough that you can let them do some very low stakes scenarios. Like for instance, the first interaction with a patient, which is kind of the thing that currently nurses sometimes do, just to do just some initial check that then the clinician would look at. So kind of like this workup. I think this is something where I think we're already quite far. Otherwise, I feel a lot of the revolution will also happen on the patient side. So right now, many people always think of like, oh, here's this hospital system. They have their software, they have their EHR and whatnot, and then they have their little avatars that take over some tasks. But I think much more will also happen in the future on the patient side, such that the patient actually enters the hospital and already has her own like assistant that knows everything about that patient's history and so on. And I think I cannot really say about readiness on that front, but I think this is just a big change that I expect will happen more, especially in settings where there's a lot of heterogeneity, like in Europe, between different IT solutions within a hospital. In the US, I think the situation is a bit different. On the question about benchmarking, could you repeat that question once more?
It wasn't really a question. It was more like I think it's a very important topic on the difficulty of benchmarking medical applications. And I was wondering if like clinician trust is factored into benchmarking. I guess currently, you know, there's a lot of work being done on designing new benchmarks that are more grounded in real world applications. And I think ethics and trust should, I guess, play a big part of that.
Yeah, I mean, the easy thing to comment there is, or the obvious one is, I think it's very important to have clinicians in the loop. This might sound trivial, but it's actually not so easy because they're very busy people, and it's not so easy to get hold of a bunch of them. And it's very easy to quickly do something without having any clinicians in the loop. It's very easy. It takes one person a few hours or a few days to hack something together. But I think actually taking this extra effort to get like a bunch of clinical experts in the loop, I think is very important. Yeah, I think that's a short answer. Happy to take it offline as well.
Thank you, Michael. That was amazing.
Thanks.
I'd like to invite Julian to introduce our next speaker.